Next area topic deals with the area of trapezoids, kites, and rhombuses. So first we're going to talk about the area of a trapezoid. Remember, a trapezoid is a quadrilateral with one pair of parallel sides. Those two parallel sides are known as the bases. So we have base 1 and base 2. All right? The area of a trapezoid is half height times the quantity base 1 plus base 2. So let's take a look and see how that works. So letter A says, in example 1, find the area of the trapezoid with height 7 and bases 12 and 15. So let's go ahead and write out that formula. It's 1/2 the height times the quantity base 1 plus base 2. All right, now I know the height is 7, and the bases in no apparent order can be base 1 and base 2, and we're just going to plug those in and calculate. So the height was 7, and in here we have base 1, 12, plus base 2, 15. So I'm going to go ahead and calculate this out. Now the first thing we're going to have to do is inside the parentheses, we have half 7 times 12 plus 15 is going to be 27. And now I can multiply these all the way across. So half 7 times 27 gives me 94.5 centimeters squared. So that one's very straightforward. Okay, the next example, if you look here, I'm going to go ahead and look at my diagram. I know I have base 1 is 11 and base 2 is 16. Now what we do not have the height. Okay, so I'm missing the height. So I need to figure that out. Now according to this diagram, I've just added the height as a dashed line. All right, this is the hypotenuse of that right triangle. Now this length down here, okay, this length down here is the entire bottom base, which is 16, minus 11. That would give me this remainder. So I know this over here is 16 minus 11. Okay, that's those two bases. 16 minus 11 is 5. All right, so to find the height, all right, I'm going to use a squared plus b squared equals c squared. So if I look at this right triangle, all right, I'll call h will be my a, so that's called h squared. B would be 5 down here. That's the other leg, so it's 5 squared. And C is always the hypotenuse. That's 13 squared. So I'm going to go ahead and calculate this out. This is h squared plus 25 equals, that would be 169. Subtract 25 from both sides, and that gives you 144 equals h squared. And then square root to get the height. So the height is the square root of 144, which is 12. Now that we have that height, we can find the area of our trapezoid. So that one had a little extra step involved. All right, so here's our formula. Now I'm going to plug in all the information I know. So that I know the height I just figured out was 12. And the base 1 was 11, base 2 is 16. All right, so let's go ahead and calculate that. That's 1/2 12, and then 11 plus 16 is 27 again. Now we can calculate that all the way across, multiply half times 12 times 27. And with that we get 162, and that would be feet squared. So sometimes it's very straightforward where you just plug in the numbers in the formula and calculate. And sometimes you're missing information, so we had to bring back some previous knowledge of the Pythagorean theorem. Okay, here's another example. We're going to find the area of this trapezoid, which it represents some type of window, maybe a car door window. Okay, so let's see what information we have. We have base 1, we have base 2, And it looks like that would be our height because that's perpendicular distance between the two bases. So that's definitely the height. So I can go ahead and calculate that's 1/2 the height, which is 18, times base 1 plus base 2. So this one working out pretty easy for us. 1/2 18, 20 plus 36 would be 56. And we can go ahead and calculate all those. 0.5 times 18 times 56. And it looks like we get 504 square inches. So that one was very straightforward. Okay, example 2, we're going to find the area of these trapezoids, and we're going to have to use previous knowledge to calculate our area. All right, so let's think about what we have so far in this trapezoid PQRS. SR right here would be base 1. PQ down here would be base 2. And what we don't have is we don't have the height. Okay, now for some reason they give us this 60-degree angle down here, which I'm probably going to have to use that. So let me draw the height right here so it creates that right triangle. I'll call that H. Okay. Now, if this angle here is 60 and this angle is 90, that means this angle has to be 30 degrees. All right, so this is a 30, 60, 90 right triangle. So this is a special right triangle. Now I'm going to use the information from this triangle to figure out that height. Okay, so what I'm going to do is I'm going to go ahead and let me refresh everybody's memory, okay, with how this triangle works. So this is a 60-degree angle. That's a 30-degree angle. All right. Now the side across from the 30-degree angle, okay, that's our short leg. The side across from the long angle, the bigger angle, that's the long leg. That's the short leg times radical 3. And the hypotenuse is 2 times the short leg. So this is kind of how that triangle works out. All right, so let's use that information to see if we can figure out the height of this trapezoid, and then we can plug it into our formula. Now, this whole bottom is 7 and the top is 5. That means this leg down here would be 7 minus 5. So that means that that's 2, okay? So that means 2 is the short leg. Now the height represents the long leg. So that means the height is going to be the short leg, 2 times radical 3. Now I have enough information. Now this says leave our answer in radical form. So let's go ahead and plug this in. All right, 1/2 the height, which is 2 radical 3 times base 1, 5, plus base 2, 7. So let's calculate that and see what we get. First thing I always do is inside the parentheses, add the two bases. That's 12. Okay. Now let's see, I can go, what I'm going to do is I'm going to multiply all of the constants. I'm not going to multiply this radical 3. I'm going to leave that as a radical 3. So I'm going to go 1/2 of 2 times 12. 1/2 of 2 is 1 times 12 is 12. And then I'm just going to plop that radical 3 on the end of it. And in radical form, that would be the area. So it's 12 radical 3 meters squared. Sorry, meters squared. All right. So that one used a 30, 60, 90 right triangle. Okay, we had one back here that used the Pythagorean theorem. All right, in that previous example. All right, let's try example B here. All right, this is base 1. All right, now this whole thing here is base 2. All right, which I do not know yet. I do know that this base 1, 4, since these are right angles, okay, that means this is also 4 centimeters between these dotted lines. So I have to figure out here, let's see, I know 7 is the height. Okay, so I got base 1, I got the height. This time I need to figure out what base 2 is. So to do that, I need to figure out what this little length is right here. All right, now if you notice, this triangle, whether it it looks like it or not, has to be a 45, 45, 90 right triangle, because if that's 45 and that's 90, this other angle has to be 45. So let's try to recall the 45, 45, 90 right triangle. So with that, the two legs are the same, okay, because it's an isosceles triangle, and then the hypotenuse is the leg times radical 2. So in this case, the height, which represents one of the legs, is 7. That means the other leg has to be the same. So this is also 7. Note it's not drawn to scale, so it doesn't look like it's 7. It's the same as the other 7. Okay? A lot of people will bring that 3, they'll put that 3 over here and think that it's equal. Well, there's no markings that say that both of those are 3. So we have to use, all right, we have to use our geometric proof here using that 45, 45, 90 right triangle to figure that out. So now that I have that little length, I think if I add 7 and 4 and 3, I'll have base 2. 7 and 3 is 10, plus 4 would be 14. So now I have all the information I need. So it'd be 1/2 the height, 7 times base 1 plus base 2. Okay, so I'm going to go ahead and calculate all this. So we have 1/2, 7 times the quantity 4 plus 14, that'd be 18. And now I can calculate that all the way across. So 1/2 times 7 times 18 would give me 63. So 63 centimeters squared. All right. So again, in recap, this triangle here was a 30, 60, 90. So we had to use the properties of that triangle to figure out the height. And this one uses a 45, 45, 90 right triangle to figure out that missing length to figure out base 2. So be aware of the Pythagorean theorem and special right triangles to help you figure out some of these problems. Okay. All right. So that is area of a trapezoid. So now we're going to talk about the area of a rhombus or a kite. Now these two shapes both have the same exact area formula. Okay, area of a rhombus or a kite is 1/2 diagonal 1 times diagonal 2. Now remember, a diagonal goes from one vertex across to the opposite vertex. Okay, so those are both diagonals of that shape. So sometimes they give you both lengths. Sometimes you're going to have to figure out missing pieces in order to get the entire length. So let's try one that's fairly easy to start off, and then we'll increase the difficulty. So here we go. We have 1/2 diagonal 1 times diagonal 2. Again, kite, rhombus, doesn't matter. All right, I'm going to call LN, this length right here, I'm going to call that diagonal 1. Okay, so that whole length is 3 plus 3. So that would be 6. And times diagonal 2, I'll take diagonal 2 would be that whole length there would be 2 plus 5, which is 7. And then I can go ahead and calculate that. 1/2 of 6 is 3 times 7 would be 21 meters squared. So again, very simple. They gave you both lengths of the diagonals, plug and chug. Okay, let's take a look at another example. All right, so in this case here we have a rhombus. Okay, so in this rhombus here, it says EC, this is 12, so that means this is 12 over here. All right, so let's write out our formula. 1/2 diagonal 1 times diagonal 2. So let's take a look. Diagonal 1 we'll call AC diagonal 1. 12 plus 12. That's 24. All right. Diagonal 2. Now diagonal 2 we do not know. Okay, that would be BD. Now, we don't know either of those lengths. I do know they're the same though, okay, because the diagonals of a rhombus bisect each other. It's a parallelogram. All right, so what we're going to figure out here, we're going to use this BC. We're going to have to use that somehow to figure out this portion of that diagonal 2. So what I want to do here is I want to take that diagonal, and take half of it, which I have right here. Okay, so what I'm going to do is take this right triangle right here. I know the diagonals of a rhombus are also perpendicular, so I know that's a right angle. So I'm going to take this right triangle right here, and let me take and pull that out of there. So that's 15. That's a right angle. This is half of the diagonal I need, and then the bottom here is 12. All right, so to figure out that little piece right here, I'm going to use Pythagorean theorem. Okay, pretty easy. So let's see, I'll make this my A. So let's leave that at A squared, and over here is B, 12 squared. And C has to be the hypotenuse, so that'd be 15 squared. All right, let's go ahead and calculate this out. This would be 144. That would be 225. So what I'm going to do is subtract 144 from 225. Okay, that gives me 81. So A squared equals 81. And I'll go ahead and square root that, and that should give me that little piece that I need. This guy's right here is 9. Okay, so this is 9, which means this is 9. Now I have enough information to have diagonal 2 is 9 plus 9 is 18. Whoa. Sorry, 18. Now I can calculate that out. So I'm going to go half of 12 times 18. That should give me my area of this rhombus, which is 108, 108 meters squared. Okay, we'll do one more rhombus. Okay. Now this rhombus, we're going to find the area of this rhombus RSTU. So let me write out my formula one more time. It's 1/2 diagonal 1 times diagonal 2. Now diagonal 1 we'll call RT. That's already labeled as 24. So we have 1/2 diagonal 1 is 24. And again, diagonal 2 is not even drawn in there. So what I'm going to do is I'm going to draw diagonal 2 in there. Okay, so that makes a right angle. It cuts that diagonal in half and this diagonal in half. So that diagonal before, the whole thing was 24, which means both of these are now 12. Okay, so now I'm going to use the Pythagorean theorem again. Let me take that triangle out of there and look at it. So this bottom part is 12, that's this part. The hypotenuse is 13, and then this is the piece I need to double it to get diagonal 2. So again, a squared plus b squared equals c squared. So a squared plus 12 squared equals 13 squared. So let's see, let's square these numbers here. That'd be 144 equals 169. I want to subtract 144 from 169. And that gives me 25. Write that down. That's 25 equals a squared. And then I'm going to cancel a squared to get a equals the square root of 25, which is 5. Okay, so this is 5 here, which makes that 5 there. So diagonal 2 would be 10. Now I can calculate. All right. Half of 24 is 12 times. Half of 24 times 10. I don't know why I wrote that twice. 12 times 10 is 120 square feet. So some of these problems are definitely going to be using some old material like the Pythagorean theorem. You got the 30, 60, 90 right triangle. You got your 45, 45, 90 right triangle. So hopefully you grasp that concept, and hope you've enjoyed the lesson.